So this is for second PU science students. So I am going to start chapter 3, that is matrices. But before starting the chapter 3, I will read out the retained portions in this chapter. Retained portions in this chapter. So these are the retained portions. I will read one by one. You can note down. Introduction, matrix, types of matrices, operations on matrices, transpose of a matrix, symmetric and skew symmetric matrices, invertible matrices. The deleted portions are existence of non-zero matrices whose product is the zero matrix. Concept of elementary row and column operations. Proof of the uniqueness of inverse if it exists. So let me start with the chapter 3. So matrix. Matrices is plural, matrix is singular. So what is a matrix? I will start with the definition. So a matrix is a rectangular arrangement of numbers, or functions. A matrix is a rectangular arrangement of numbers or functions. So how to represent a matrix? The next question is how to represent a matrix. So first I will generalize, then I will give examples, suitable examples. So a matrix is represented using capital letters. So you can write any capital letter A to Z. So remember, to represent a matrix you should give capital letters. And what about the elements? Because every matrix has some elements. The elements should be written within square brackets or round brackets. You can use either square brackets, pair of square brackets, or pair of round brackets. So I will give the generalization first, then I will give examples so that you can understand it. So matrix A is of the form A11, A12, dash, A1M, A21, A22, dash, A2M, and so on, dash, A1N, A2N, A11, A12, dash, A1N, A21, A22, A2N, AM1, AM2, dash, AMN. Now you can observe here, this is one horizontal line, this is one horizontal line. Like this, there are many horizontal lines. In fact, there are 1, 2, up to M horizontal lines are there. These horizontal lines constitute what are called rows. So these constitute what are called rows. So this is the first row, this is the second row, row 2, row number 2, and so on. there are m rows here. M rows here. Horizontal lines forms rows. Now consider like this vertically, that is vertical lines. So A11, A21, dash dash, AM1. Okay. So here these vertical lines will form what are called columns. This is one column, say column 1. Again this is column 2, column 2, and so on. Here there are n columns. This is the last one, so column n. You observe here, so there are m rows, one row, second row, and so on. This is the mth row. Here if you take like this, column 1, column 2, and so on, column n. So there are m rows and n columns. We call this as m cross n matrix. We say that the matrix A is of order m cross n, order m cross n or m by n. So a matrix will be of order m by n or m cross n if it has m rows and n columns. So number of rows will specify first m and next number of columns. Okay. So that is generalization. Now you observe here I have given just representation A11, A12 dash dash A1n. It means that say I am A11, I am referring to what? First row, first column. A12, first row, second column element. And so on. A1n, I am referring to first row, nth column element. Same way if you consider, this is again same, first row, first column. A21 means second row, first column element. And so on. AM1 means this is mth row, first column, column number is 1, row number is m. AM1. So column is okay 1, row number is m, row is m, column is 1. What about this AMN? AMN means what? That is mth row element, nth column elements. These are all called elements of the matrix. A11, A12, A1n, etc. A21, A22, etc. are all called elements of the matrix A. Elements of the matrix A. This matrix is of order m cross n. I will explain it with some examples. I call it as let A equal to 1, 2, 3, 4. Okay. Let A equal to 1, 2, 3, 4. So what can you say here or what you observe here? How many rows are there? There are 1 row, 2 rows. So 2 rows, 1 row, 2 rows. Second row. Similarly, how many columns? 2 columns. So I can say A is of order 2 by 2. So I will write like this using this symbol. So it is of order 2 cross 2. It is written as 2 cross 2 or 2 by 2. So A is a matrix of order 2 by 2. So 2 cross 2, 2 by 2 or 2 cross 2. So what is the meaning? It has 2 rows, 2 columns. Next example. B. Let us B equal to, so 1, 2, 3, 4, 5, 6. Any numbers can be given, not positive only. You can give negative also. Okay, 1, 2, 3, 4, 5, 6. B is a matrix. But what is the order of this? Its order is, if you observe carefully, how many rows are there? There are 1, 2, 3. 3 rows are there. How many columns are there? Columns means vertically you have to consider. Rows means horizontally you have to consider. So vertically, if you consider horizontally, horizontal line 1, 2, of order 3 by 2. So we can have any order 2 by 3, 1 by 4, 4 by 1. So remember, first element, what I am writing here represents the number of rows. The second one, 2 here, represents number of columns. So this is how we can write matrices. But remember, capital letters here, A here, A or B here, the name of the matrix, how to represent, use capital letters. I will give one more example. X equal to, say, xy. I am writing xy. Okay, this is of order what? So 2 rows, 1 column. You observe here, it is of 2 by 1 matrix, 2 cross 1 order. Important point here, I have written x here, here also x, here y. Important point to be remembered is, this has to be capital letter, and the elements, whatever you are writing, if at all you are using letters, use small letter. So this x represents what? This x represents, it is a matrix. What about this x represents? Small x represents that it is an element. It is an element of value of x, matrix x. So this is used, capital X is used to represent this entire thing, matrix. Whereas small x tells you that it is an element of x. Similarly, of course, y is also an element of capital X. This x stands for matrix. This x stands for an element of the matrix X. This y stands for an element of the matrix X. So this is the point you have to remember. So capital letter, small letter. So capital letter should be used if you are representing a matrix. Small letter should be used if you are representing elements. Okay. That is representing matrices. Next we will see what are the different types of matrices. Types. A row matrix. First one, row matrix. Row matrix. So it is a matrix having single row. So only one row is there. So you can easily remember a row matrix. So if I write A equal to 1, 2, this is a row matrix. So only one row is there, but you can have 2 columns, there is no problem. Only thing is, we call it as a row matrix if it has a single row, A row matrix. A what stands for? A stands for single or one also. So A row matrix, you can easily remember A row matrix. A row matrix. So this A stands for one or single. So only one row. A row matrix. So this is an example for a row matrix. Of course, what is the order here? 1 by 2. Of order 1 cross 2. We call it as 1 by 2 or 1 cross 2. Okay. So this is also a row matrix. 1, 2, minus 3. I have given some negative number. So I told you already it can be negative value or positive value. So 1, 2, minus 3. So it is a row matrix. B is a row matrix of order 1 cross 3. Next, column matrix. Column matrix. Column matrix. Okay, name suggests that is only one column. So A column matrix, easily you can remember A column matrix. A column matrix, Example, x equal to only one column. So A, B. So there is only one column, but two rows are there. The second part, and second one here, only one column. So this is a column matrix. A equal to, one more example, 1, 2, 3. A equal to 1, 2, 3. This is also a column matrix, but having 3 rows. So this is 3 cross 1. But it is a column matrix, 3 cross 1. Here, 1 important for us, for column matrix. So name itself suggests a row matrix, that is a single row is there. A column matrix, a single column is there. Okay, next topic. Next type, null matrix or zero matrix. Null or zero. Again, name itself tells what it is. Name itself tells null or zero matrix. So, what is the meaning? Or what it tells? It tells that all the elements are zeros. It tells that all the elements are zeros. I can write a matrix like this, but generally null matrix is represented using this symbol. So I will use this symbol. So for example, 0, 0, 0, 0, 0, 0. So this is all the elements are zeros here. All the elements are zeros. So that is why it is called null matrix. Remember, all the elements should be zeros. So it is of order 2 rows, 3 columns. So 2 by 3 order null matrix. All the elements should be zeros. Remember, if I write for example 0, 1, 0, 0, it is not a null matrix. It is not a null matrix because there is one element 1 here. There is one non-zero number here. So this is not a null matrix. All the elements should be zeros. Remember. So it is a null matrix. So just remember, null or zero matrix means all the elements are zeros. Next, rectangular matrix. Rectangular matrix. A matrix is said to be a rectangular matrix, or a matrix is said to be rectangular if number of rows is not equal to number of columns. Number of rows is not equal to number of columns. So important, rectangular matrix. Number of rows not equal to number of columns. One example. A equal to 1, 2, 3, 4, 5 minus 1. So how many rows are here? There are 2 rows, but 3 columns. These two are not equal. So a matrix is said to be rectangular if number of rows is not equal to number of columns. Here, example A, 1, 2, 3, 4, 5 minus 1. I have written like this, where there are 2 rows, 3 columns. So it is a rectangular matrix. Rectangular matrix can be a null matrix also. For example, if I write like this is also a rectangular matrix. Of course, it is a null matrix. It is a null matrix as well as a rectangular matrix because here there are 2 rows, 1 column. 2 rows, 1 column is there. So it is again a rectangular matrix. Just remember, if number of rows say m not equal to number of columns say n, then it is a rectangular matrix. Now the next question is, you may ask, what happens or what you call if number of rows equal to number of columns? The next point is, if number of rows equal to number of columns, such matrices we call in which number of rows equal to number of columns. So if m equal to n, number of rows equal to number of columns, that is a square matrix. Square shape, you know. This is a square shape. So why we call it a square shape? Because you know length and breadth are same. All the sides are same length. Same concept here. Number of rows equal to number of columns. So then it will become a square matrix. So I will change the example. Now I will give an example like this. Let A equal to 1, 2, 4, 5. Is it a square matrix? Yes. How can you say it is a square matrix? There are 2 rows, 2 columns. So it is a square matrix. Okay. Even if I write only one element like this is also a square matrix. It is of order 1 by 1. 1 by 1. Only one row, one column. If I write one more example, C equal to 1, 2, 3, minus 5, 6, 8, 3, 4, 5. This is again a square matrix of order 3 by 4. Okay. Now consider, these are the example for square matrices. Now consider elements from top left to bottom corner here. These elements 1 and 5 or 1, 6, 5. This example. This line is called the diagonal or main diagonal. So we call it as the diagonal elements. 1 and 5 are diagonal elements or main diagonal elements. Similarly here in this example 1, 6, 5 are main diagonal elements. Note that these are called diagonal elements or main or principal diagonal elements. These are main or principal diagonal elements. So 1, 5 here, 1, 6, 5 here. So what is that diagonal elements? So we know that these are diagonal elements across this line. What are the elements here? 1, 6, 5, 1, 5 this example. Okay. Why I require diagonal elements? For the next type, that is what is called diagonal matrix. So now next is diagonal matrix. So what is a diagonal matrix? A diagonal matrix is a square matrix. Basically, it is a square matrix in which the non-diagonal elements are zeros. So diagonal matrix is a square matrix. First of all, it is a square matrix in which the non-diagonal elements are zeros. Example. A equal to 1, 2, 0, 0. These are all 1 and 2 are diagonal elements. They may or may not be zeros. Whereas these non-diagonal elements, these are called non-diagonal elements, are zeros. So non-diagonal elements are zeros. These may be zeros also, but the important point is the non-diagonal elements should be zero for a diagonal matrix. Next, scalar matrix. So I think diagonal matrix means just remember non-diagonal elements are zeros. Next one is scalar matrix. A scalar matrix is a diagonal matrix with some condition. A scalar matrix is a diagonal matrix. Scalar matrix, it is a diagonal matrix. Diagonal matrix. A scalar matrix is a diagonal matrix with the additional condition that all the diagonal elements are equal, with the condition that diagonal elements are equal. So if I write like this, say 2 and 2, if I take this example, A equal to 2, 0, 0, 2, then it will become a scalar matrix because the diagonal elements are same. The diagonal elements are same. I will give one more example. 1 0 0 0 1 0 0 0 1. Here you can observe here all the non-diagonal elements are zeros. So this is 0, this is all the non-diagonal elements are zeros, and the elements here, some elements are there which I have taken as 1 1 1. There is a purpose here. Why I have taken 1 1? Here all the elements are equal.